Okay, so in this case, we're actually going to keep even more minimal. So now, in order to create a pathway, we're going to just, again, use the idea of creating a pathway from a center line. But in this case, we aren't even going to draw that center line. We're actually going to just reference 2 points to create kind of a rigid idea of where the start and the end point of our pathway. It's obviously still going to have a lot of dynamic features, but in this case, all you are really manipulating are these 2 points in Rhino, so you can start to move them around and everything will respond accordingly. So again, I'm going to go ahead and use this as my start point, so set 1 point. I'm going to just copy and paste and say set 1 point. I use this, so again, I just have these 2 points. So from here, I'm just going to create a line from 2 points, right? So here's the start and here's the end, okay? And it's, again, all we are going to be doing is manipulating 2 points in Rhino to essentially get us from literally point A to point B. So from here, what we want to do is, kind of like in the previous videos from a from a center line, we're going to divide this by a number of points, and those are what we're going to really start to manipulate. So I'll start with a decent value of something like 35 here. Okay, so here though, this is where we start to, again, kind of create something a little more fluid in terms of the pathway. So what I'm going to do, again, I'm going to use the graph mapper. It's one of my favorite things to create these pathways with, because there's a lot of different kind of variations we can create. So again, I like to remap these values, or sorry, so I'll use the range to do that. So range, so 0 to 1, number of steps, so what's great is whatever you have going into your divide component, you can put into your range component, and it just remaps those 35 values between 0 and 1. And again, this, you don't have to add an expression, you're still getting 36 from this, same number that's coming out of this. So it's one less thing to have to do if you just use the slider. So from here, I'll go now to my graph mapper, and we're gonna, again, play with two different axes. So I'm gonna change this to a, let's try the, sine. And so I want these to actually go in both directions, or both sides of this curve. I don't want them to just be on one side or the other. So in this case, I double click, so instead of going from 0 to 1, I want this to be -1 and 1. So that way, ones that are in the negative value will go to one side, and the ones in the positive will go to the other side. And again, I want to make sure that they go according to, or staying perpendicular to the center line, so that's what I use this for. So curve, and I want to just make sure to, again, maintain. Let's use the horizontal frame. I think that's fine for this. So here's the curve, here's the parameter value to create these frames, and again, no matter where I put it, they'll stay. Even if I start to do it vertical, right? Everything will stay perpendicular to it versus assigning it a actual frame. So from here, so I'm going to use this to help me determine the direction. So I basically want these points going along this green axis on either side, right? So that's our y. So I'm going to go ahead and deconstruct my frame. So vector, deconstruct. And like I said, I'm using that green axis, which is the y value. So this is what's going to move it to either side. So now I can go ahead and use the move. And what I'm moving are the actual points. That's over here. I can turn this stuff off since I've already figured it out. But I want to also use those values. So this is where you can assign actual value to those directions as well by using the amplitude component. So this is again using the direction, which is the y. That plugs into there. So you can see they just default by whatever that amplitude is, which is a 1. So they're all just going to that side versus on both sides, and that's what this is going to do. And I want it to go more than one value on either side, so I'll just go ahead and use a multiplier here. And use something like 5 for now. So it'll be 10 feet wide. If I want it to be 6, I have it at 3, so it's basically just going to double whatever that value is. So now, or sorry, no, this actually is the width. Sorry. So let's go ahead and plug that into there, and now we can see that we'll turn off these other items, right, to show how you can create that path. So in order, like you can see that the original points are off to the side. I can kind of create a number of kind of serpentine curves on this. If you want those to match up perfectly, you have to basically kind of have them, basically think of this as the 0 value, so the original point. So if you want to, you have to basically drag that into that other end, right? So that looks like it's pretty close. That's pretty reasonable. Obviously, now they're only going to be going on one side. You can see that they're pretty much staying on that way. So that's just kind of something if you want to decide. There's other ways to do it as well. If I do the graph type Bezier and I just make sure that, again, these points are at the origin. So at that 0 value, you don't get as much of that kind of range or number of curves, but you can still use it to create some different curvature to this, and you can always exaggerate it more by kind of sliding that. Can use the purlin, and again, as long as we find a way to get those to match up as closely as possible, which can be very difficult, especially with this one. If we get kind of close, that's always helpful. Right, I can try to find an area where they're more or less kind of ending in the same area. Right, that one's pretty close. That looks pretty good. Okay, so now we've got it moving on both sides. But again, this is just a flat path. We also want to look at adding some height to it as well. So now I'm going to, again, move these. But instead of using this direction, I can just use simple z value. And I'll, again, just copy and paste this. I'll change this to go from 0 to 1, so basically it stays on grade or above. If you want it to go below grade, then you can keep it at -1. I'm going to change it to, again, the sine curve here. So this is going to have a max value of 10 in some of those areas. So you can turn this off now, and so now, again, I'm kind of have it go like this. If I want there to be multiple curves, I just kind of keep dragging that. Sometimes you want to think about having a smoother kind of transition from that elevation change. So if you want, you could always use the Gaussian one so that you can kind of see where it kind of stays flat and then it peaks up. That's always kind of a good one. Again, you're only going to have one of these heights, but you can still have some fun with it to create various height conditions. So now we've, again, kind of got it going in multiple directions, both the x and the y, and now our z value. So again, it's just, this is basically just a series of points that we don't have any dimension to it either. So that's the next thing we actually want to do. So again, I'm going to take these now and I'm going to go ahead and create a curve from it. So again, it's going to require a lot of kind of constructing, deconstructing, reconstructing, but that's just part of the process, right? So we can see that this is still kind of maintaining those two original points. And again, what's great about it is I can always just continue to move my 2 points and have everything respond. So it could be really short, could be much longer, right? Be a lot more subtle that way, or less steep. You have a lot of control over it by just having to move 2 points, which is nice. Okay, so let's just kind of keep with something like that. So like I said, now we want to start to add some dimension to it. So unlike the other ones where we used a rectangle, in this case we actually are going to use the line SDL to do this. So again, in order for that to work, I need a series of points. So I'm going to, again, divide this curve by a series of points. You can use the divide, you can use the divide by distance or length. It really doesn't matter because we're going to get the same type of outputs, which is really what's important. And again, I'll stick with something fairly dense, so 40 in this case. Obviously, you can use the same one as before, or you can use an entirely different one. It really doesn't matter. So I'm going to just keep it, again, kind of dense. And again, in this case, I want to use the horizontal frame to do this. So here's my curve, here's the parameters, and again, it's going to keep everything nice and horizontal. What we would want in an actual pathway, we don't want it to start to kind of undulate in different directions. If you use the curve frame, you'll see you get a much different result using this one, where they start to kind of go based off of the curvature of that curve. So we just want to keep everything nice and horizontal like this. And again, we want to make sure that we're using the correct axes. So again, it's all going to be based off of the Y, or you can see these green axes lines. So again, I'm going to go through a very similar process of deconstructing my plane here and using that Y for my amplitude of the length of these curves. So I'm going to use, again, the curve line SDL. So this is going to dictate the width of my pathway. So the start is, again, just these origin points. And I'm going to need to go it on both sides. So I need to remember that the direction can stay with one of these, right? So there's that one, and then I want it to go in the opposite direction. So I can't just plug this into there because then it's just going to mimic it. So I actually want to reverse that direction. So I need to go to vector, vector, reverse. And now you can see that we've got it going on both sides. And again, this is one of those things I could just, if I want this to be nice and uniform throughout, I can just do a number slider and just remember to drag it into both of those, right? So you can do it like that. I'm actually tempted, I haven't tried this yet, but I was just thinking, I wonder if I can still use that same direction, but just make this one a negative value. Oh, so yeah, that's another way you can do it. So if you don't want to reverse it and you just use that same thing, you can just have one as a positive and the other as a negative. So it's just one less component, you just have to add an expression for it. So yeah, that's another way to do it. But again, I don't like to have everything so kind of uniform, especially when you're using parametric modeling. We have the ability to give a lot of variation to it. So again, I'm going to go that route. So I'm going to just get rid of that. And now I'm going to, again, use my favorite graph mapper component. I'm going to use that same process as I did in this previous step. So I'm going to, again, Go to sets to create a range of values. Use the same slider for this. Graph type. And I can, again, just pick whichever one. I'll stick with the sine for now. I'll give it a multiplier. That way I'm basically just having to minimize my editing of this. And again, I'm just going to drag that into there now. And so now we can see again, probably don't want things to be at 0. So if you want, you can just say, you know what, by default, it's going to have whatever that multiplier is as the smallest. And then I'll use 2 to basically double it for whatever that peak of the graph is. And then I can, so the minimum is maybe 4 or 5 feet. That's generally going to give you a nice ADA accessible one. You can always kind of adjust it this way, so you can have a bunch of different kind of curves going on with this. Create something pretty interesting and fun. All right. Okay. So again, this is basically just going to mirror it on both sides, but in some cases, maybe you want to actually give it some different type of variation, so it's not essentially symmetrical on either side. So in order to do that, we'll have to have 2 graph mappers, but I'm actually going to just plug it into one. Sorry, I'm just going to copy and paste this one. I'm going to pick a completely different graph type. In this case, I'm going to use the Gaussian one. So now I just have there's just going to be one giant peak. So I can have it go out really far. Now I'm just going to use that one for this one. Right, so now I have 2 different kind of curves on either one of these sides. If I want it to really kind of shoot out, I can do something more like that. I can always make that side a little bit more narrow. Put this wherever I want, so now we get a little more variation to this again too. If I want, I can even use the purlin to have a bunch of, it's kind of similar to the sine, but it's a little more kind of randomized essentially. Right, so one can be really smooth, the other side could be a little more jagged, so to speak. And then I can really amp it up a little bit more. Right, so a lot of different kind of styles. If I wanted to just have a couple of these, it doesn't give you as much kind of, I think, diversity as the other ones, so you can just kind of decide on which one you want, right? So again, a lot of different styles. We can begin to go with these, so you can have a lot of fun with it again. And I think these are just good tools to use to kind of give you a lot of kind of diversity. So I can almost start to see as this is some kind of like little alcove, or it could be either a lookout, it could be a little resting place on this pathway. I can move that to wherever I want. I mean, I kind of like it wherever that high point is, right? So I just kind of move it over until it's right in that area. And again, that's all being built off of the height, which is here, which is, again, also a Gaussian one, but we start to see a lot of kind of flexibility in our pathway here. So these are, again, just 2 line segments, so I want to actually go ahead and join them. So I'm going to go to Curve, Join, so they're all just one single curve, right? I'm going to turn off everything else so it's just a little bit easier to see. And again, it's all from those 2 points. And now from here, I can actually create a solid surface of this. So I'm going to just go to Surface and use the loft component. And there we go. So now we have our lofted surface for our pathway. Creates, again, something really kind of interesting, more kind of this cool ribbon effect. And again, I can dictate where I want it to start, where I want it to end. Oops, how long is it? Oh, it keeps wanting to grab the blue. Let's try it. Right, if I want, I could start to even give it some elevation, right? It's kind of cool that way. Or I can just continue to keep it basically on those two footprints. But again, it's a good way to show how you can create a pathway just using 2 points. And again, this is going to be one of those tools in moving forward. We'll continue to expand on this. But for now, it's just to get the idea of kind of, instead of using a generic curve and rhino, if you want to just get something a little bit different, you do it this way. And instead of using those rectangles, we'll actually use these kind of curves for their lengths to design it. So again, some variation for it. What's cool, if you still want to have it kind of like a boardwalk, you can always take this and go to Lunchbox and add panels, right? So maybe you still want it to have kind of that feel to it. So I can go to here, can have it kind of, I mean, that's kind of interesting with the boardwalk where it has some variation in height or width. If you want it to just be one single panel, you can drag it into, oops, not that one. Let's put into the V value, right? So now they're just almost like various type of panels or decking. If you want to kind of maintain that original, you just really want to increase the density of these. If you want them to be smaller or wider, you just decrease the size of this. It kind of can create something a little more kind of rigid, which is kind of cool looking too. So instead of having that original really kind of soft and organic, if you create just a minimum number of panels, it kind of creates something more like that, which is kind of cool too. So yeah, again, this is just another variation to show how you're creating a pathway from 2 points.